Hello guys. I want to talk a little bit about my favorite module that controls other modular gear in my eurorack system. It is the micro16mcc from Flame, a German manufacturer, and it converts MIDI-CC controller values to control voltages. Simply speaking, it is capable to convert pitch bend data coming from a synthesizer to control voltages, which further can be used to modulate other eurorack modules like VCA letters, oscillators, filters, and so on. The module can not only convert pitch bend values from a synthesizer, it can convert any CC controller value in any MIDI channel to control voltages, for instance from a digital audio workstation, but also generated CC controller values from a microcontroller like an Arduino. 16 channels corresponding to 16 individual control voltages are available. That gives a huge amount of possibilities to control modular gear. For instance, envelopes or low-frequency oscillations can be generated. Additionally, the module can be used as a trigger sequencer. Moreover, note pitches can be generated as voltages per octave for melodies. And keep in mind, this can be done on 16 individual channels. So, honestly, it is a kind of a cockpit that allows for controlling modulation, sequencing, parametrization, and in combination with other modules also generative music production. The basic setup is as follows. I have connected the micro16mcc via MIDI adapter cable to the MIDI interface. The MIDI interface is connected to the computer via USB. To start with, some configurations of the interface have to be done. The manual gives a detailed description about the configuration process, which can be done manually or via sysx dump. In my configuration, all MIDI data must be sent via MIDI channel number 1, and I use the controllers 1 to 16. However, you can make your own configuration according to the actual needs. So, let's start a short demonstration. At first, let's make some modulations with the help of an LFO that is constructed in Ableton Live. I use the voice from Erica Synths as an oscillator. I adjust the MIDI output port and the MIDI channel in the track setup. In the clip envelope setup, I select the controller number 1. That corresponds to the output 1 of the module, which I have connected to the volt per octave input of the oscillator module. Now I can draw some envelopes into the clip. By adding more clips and clip automation, different modulations can be triggered. Next, let's see how to make a trigger sequence that controls the voltage-controlled amplifier of the oscillator module. For this purpose, I use the controller number 3. That corresponds to the output 3 of the micro16mcc module. That goes to the trigger input of the oscillator module. After choosing the right MIDI output port, the right MIDI channel, and reducing the decay time of the oscillator volume, the trigger sequencer works as expected. Finally, Drawing of discrete controller values instead of envelopes allows to make melodies, as shortly presented in the next example. Combining all sequencing and modulation opportunities allows for the rapid construction of tracks. Herein I have used an additional bass drum and hi-hat.